Hello and welcome to the Grid Podcast, our podcast about the electricity networks across the UK and how they're at the heart of our transition to net zero. I'm Brian Murhead, Grid Connection Manager for eSmart Networks in the host seat today, and I'm joined by our Technical Director, David McDonald. If you want to say hello, David.
Hey Brian, good to be back.
And today we are talking about a big topic that is right across the industry at the minute, and that is transmission capacity. And I think just about any developer or investor in the renewable or battery space will have learned a lot about transmission capacity probably in the last year or so.
I think so. There's been plenty of articles about it and it's a hot topic in the industry at the minute.
Yeah, and there's a lot of different misunderstandings out there, I think. I think there's a lot of confusion around why this is impacting pretty much any renewable project or battery storage project today. And we thought, well, let's pick through it, break it down. Let's do a bit of a summary on what the issue is, look at the challenges and look at some of the solutions then.
Yeah, no, sounds good. And this is maybe going to be our first run of a mini-series, is that right?
Well, I think basically when we sat down to think about this topic, it is so huge. There's so many strands to it. We're going to try and break it down then into, let's do a mini-series of little short episodes, break it into kind of nice, easy chunks for people to digest. So we will start with a bit of an introduction, a bit of scene setting, cover some of the background around the transmission network, how it differentiates itself from the distribution network, how it interfaces and works with or doesn't work with the distribution system, to give that kind of background, because some listeners will be more familiar with transmission connections, some won't have any experience with them. You know, most developers, investors, basically anybody, daily people in their daily lives only ever really come into contact with the distribution system.
Yeah. No, there's a lot of different players there, so I think it'll be good to get those kind of ironed out and understand where all the moving parts are, which would be great. Yeah,
so we'll cover a bit of background on the transmission network, a bit around what, just high level, why these issues are now occurring on our transition to net zero, and then we'll break it down and do a bit of a deeper dive in our follow-on episodes in the mini-series as to what those challenges are. We're probably going to break them down into two categories, one sort of process-related challenge and the other around the technical or the engineering challenges, and then looking at some of the solutions that are being progressed across the industry at the minute. And that is, just before we go any further, it is worth saying, National Grid are kind of stepping up to the mark now with a lot of solutions. They are progressing a lot of different work streams to try and fix this. Everybody is aware this is a big issue. And then at the very end, we're going to round it all off by giving you our take on, if you're an investor or a developer in the renewable or battery space, or maybe you're an engineer working in the space as well that's interested, or just anybody from regulation or anywhere involved in the energy sector. Basically a bit of advice from us on our take of, well, what does this mean for you? How should you plan your business around this? How should you be looking at connecting your projects that you're developing in 2023, and what do you need to plan for? So I think
sounds like a good plan. Do you want to get into it? So what is the problem then? What is the problem with the transmission network or the connections?
So basically, the problem in a nutshell is if you want to develop a new solar farm, wind farm, battery storage project today, anything about over a megawatt. So you could be a community energy scheme, you could be an industrial park owner who's just looking to add a couple of megawatt of solar to help decarbonize your carbon footprint, or you could be a large scale developer who develops greenfield sites, whether it be battery or wind or solar or whatever. You are going to be affected, and basically this is going to be one of your biggest challenges.
Yeah, because like the industry kind of initial thinking would be transmission capacity means a huge big connection, as in terms of a 50 megawatt solar farm, 100 megawatt solar farm, but it's impacting further down. We'll get into the detail, but it can right across all projects.
Yeah, so like I suppose historically that you would have had that 100 megawatt threshold where the kind of the BEGA, I'll not go into that, but where you would have had bilateral agreements with National Grid, if you were connected at distribution level. But obviously we've got to the point now where even, if you're a 1 megawatt solar farm, there is a transmission capacity kind of issue or interface that you kind of need to be aware of. So basically, in a nutshell, if you're in any of the above categories, you're most likely to be getting back connection dates of 2028 at best. I think probably most people at this stage would be quite glad to see 2028, as probably most dates are coming back in 2030, 2035, 2038 in some cases.
Yep.
So it's mid to late 2030s, depending on where you are across GB.
I suppose, I mean, it's important to say these are for like future projects, and like all the projects that are already in line, in tow, in construction that have offers, they're building out and connecting. So this is looking at applying now, and what does that look like 10 years from now then, isn't that right?
Yeah, basically. So obviously there's a lot of projects out there that have their connections secured, will be building out. This is mainly focused on if you're looking at a new project today, or perhaps, probably quite a few people who have applied to distribution level in the last kind of year probably will be finding that they're affected by this. Some maybe even the last kind of 2 years. Again, it is worth checking if you have a project where the application went into the DNO in the last 2 years. You definitely want to just double check that statement of works or project progression, transmission. There's a lot of industry lingo, but effectively that transmission capacity.
Okay, so back to basics. What is the cause, and how's those networks run?
Yeah, so effectively the technical issue we're talking about here is the distributed generation across the GB network has just become so fast that it's pushing power back up through onto the transmission network. So it's effectively transmission networks like your motorway system across the UK, and it's the volume of traffic at all the little local levels is now got so great. You have this rush of cars, for want of a better analogy, up onto the motorway network, and you've got gridlock on your motorway. Now, I say that's the engineering, technical rationale behind it. But as we unpick this, there is a big question as to, well, how much of this is actually a real network capacity congestion issue, and how much of it is just a queuing and process issue.
So you're sort of saying like virtual cars and real cars, are you?
Yeah. So how much of this is, it is predicting that that congestion? How much of it is actually true congestion on the network?
Okay. So
that is a point worth bearing in mind, and that'll feed into some of the solutions that National Grid and others are progressing. So that's at a very basic analogy. The large power lines that you see, the big tower circuits, are starting to get congested just with the sheer amount of and volume of distributed energy. And I suppose we're seeing this now in GB for the likes of ourselves that have background in the Northern Ireland and Irish power sector. This was happening in Ireland 7, 8, 9, 10 years ago.
Yep.
Much smaller system, much higher levels of renewable penetration. Island of Ireland's in around the 40 to 50% of annual electricity consumption from variable renewables. Any kind of developers that have been active on the island of Ireland will be relatively familiar with this type of issue.
Yeah. And I suppose there's learnings to be taken even from what was done in Ireland and the Ireland system across to GB as well. So like it's not that this can't be solved. There's plenty that we can do to make it better, and even just on a fundamental level. I know we don't want to get into locational signals and all that kind of good stuff, but load beside generation kind of does away with a bit of this issue as well, doesn't it? Because like ultimately a transmission network is transmitting it from A to B, and if you only have to go a very short distance, or the load and the generation are co-located, then that really does sort of help solve some of that too.
Yeah, and I think trying to use generation, renewable generation on site is one of the kind of key ways of maybe unlocking a few projects if there is certain circumstances. But we'll get into that at later down the podcast.
Getting too excited.
Yeah, you're jumping ahead of yourself. So we'll get to what ways to work around things. I think then as well, so just to cover a bit of the background and the scene setting, if you look at basically a National Grid map online, it'll pretty much tell you what a lot of renewable developers will know. Pretty much every grid supply point substation across the UK or Great Britain in particular, predicted connection dates, are 2027 at the very earliest, right out to sort of 2037, 2038 plus. And that varies a little bit depending on where you are around the country. The best kind of dates for generation are close to London, but obviously who's developing a wind farm in the middle of London, and that kind of comes counter to your point around location as well. So obviously there are just some physical restrictions that nobody's ever going to overcome. So as well, for part of the background, I do think it is worth noting that this is all taking place in the context of the biggest revolution we've seen in our electricity and energy systems since they were probably originally rolled out. Where the pace of change towards renewable sources of and electrified energy use is faster and larger than we've ever seen, and it really has reached supercharged levels, which is great. It's great to see the appetite out there to electrify energy generation, and also to electrify energy usage as well, and transition everything towards that net zero world. But it is a monumental engineering challenge, and I think it is just worth noting that before we delve into some of the nitty gritty.
Yeah, no, totally. It's a completely different world than the industry that I joined, and I'm not as old as maybe I look. So yeah, certainly in the last 5 years, it really has gathered such momentum, and it's a great industry to be involved in, and it brings to the fore some solution solvers and problem solvers now as well, which is great from an engineer's perspective.
And I think just to kind of highlight that, I seen a quote from the National Grid CEO, and I'm just going to, apologies, I'm just going to read it verbatim off my notes here. He said, "We will need to build about 7 times as much infrastructure in the next 7 or 8 years than we built in the last 32. I think that, that quote in itself, that need to build 7 times as much infrastructure in the next 7 or 8 years than we built in the last 32. That there is a monumental engineering challenge ahead of everybody across the energy sector here.
Okay, so let's get into a bit of detail on this then. What about connections, developers with distribution connections, knock-on effect to the transmission system? How does that all work its way through?
Yeah, okay. So some people listening might be quite familiar with this, but we're going to just sort of maybe step it through just in case some people aren't. So loads of people will be familiar with distribution connections. It's a fairly straightforward process. It's a fairly well-known process. It's quite well standardized across the ENA, and you normally deal with one party, the distribution network operator. So what's basically happening is the distribution network operator is connected to the transmission system. The transmission system is now starting to creak a little bit because there's so much capacity or huge capacity to get onto the transmission system. So basically at the minute, if you apply for anything more than a megawatt, pretty much anywhere in the UK, the distribution network operator has to refer that to the transmission system operator for them to basically check, what's going on in the transmission system and potentially identify transmission works and then come back to the DNO.
Yeah, for renewable connections and battery storage as well.
For renewable and battery storage.
Yep.
And we're now starting to see it actually affect demand connections as well, but that's probably a different podcast for a different day. So let's just to recap, distribution network operators, they're the people that bring the electricity right into your house, operate from low voltage right up to 132 kV. There's 7 regional DNOs, distribution network operators, DNOs for short. And there is then one transmission system operator who is National Grid, ESO. And then you've got 3 transmission asset owners, NGET for England and Wales, which is National Grid Electricity Transmission. And then you've got SPT and SSE Transmission in Scotland. The 7 DNOs typically follow very standardized connection processes and policies, which are governed by standardized distribution licenses and also efforts by the Electricity Network Association to really standardize a lot of policy and process. So I know some developers might be sitting laughing when I say this. It is a relatively standardized process, no matter what DNO you go to. There is quite a lot of process, policy and guidelines set out by the ENA that standardizes it across all the DNOs. And I think you would probably recognize that has come about through a huge amount of work by the ENA.
Totally. The Open Networks project has done a huge amount of work in bringing all the sort of DNOs together and coming up with those standardized processes, taking the best from each company and trying to standardize and have like a best practice guide, which lots of the DNOs are following now, which it makes a big difference for developers who are, one day in Yorkshire and the next day in Wales. Yeah,
exactly. And the key thing, just the reason I'm sort of setting that up then, the key thing to note then is National Grid are a party to the ENA, but they sit in a totally different license and regulatory framework. So a lot of the processes and everything that's been established by the ENA applies only at distribution level. Most of it doesn't read across to transmission level.
And a lot of that's historic too, isn't it? Because we used to joke in terms of, when you're in a distribution network, you have thousands of customers. When you're a transmission network, you've got like, not, you can count them in your hands or whatever. Like it's a different, it's a sort of whole different process now in terms of that connection to a transmission, where it didn't used to be that there would be very many applications going through that process in any type of regular basis.
Yeah, so if you think like anybody connected to the transmission system used to basically consist of the DNOs with their grid supply point substations, and then handfuls of large thermal,
power stations,
nuclear, gas, or coal power stations, which you could probably count on, well, like an Excel spreadsheet or something. Maybe not enough fingers, but so there didn't need to be much process around that. You had sort of once in a blue moon that somebody was connecting, and obviously that has now exploded. There's been an absolute avalanche through all the great interest in developing renewables and battery storage. And I think at the minute there's over 1,000 generators in the transmission queue looking for direct transmission connections, on top of the many, I don't know, thousands, hundreds of thousands at distribution level. So that has kind of come out of the blue at National Grid. You could argue that they should have predicted it with renewable targets and everything else. But in any case, that's kind of come into a system that was geared up to process, I don't know, half a dozen connections a year.
Well, it wouldn't even have thousands of connections now at the minute.
Yeah, exactly.
I think that's a really helpful scene setter, Brian. Gives a real clear view of transmission distribution systems, how they all kind of interact together. So what are the key problems or challenges, or what are the solutions to get this moving and to try and make some progress towards net zero and the targets that have been set? Yeah,
so we'll cover some of the challenges, solutions, just very high level now, just to give a bit of a flavour, and then in one of our follow up episodes in the mini series, let's call it, we can delve into these a bit deeper. So I've kind of split them up into kind of two categories. So process related and then sort of more technical or engineering related. So to deal with the process related challenges first, we obviously have this issue where connection process is not aligned between distribution and transmission. So effectively, you've got an inflow of generation or battery storage projects through that distribution.
Yep.
They apply to the distribution operator. They then have to make a secondary application back to the transmission network operator to find out, what the transmission impact is. There's a connection offer comes back to the DNO, and then they come and inform the developer. And we're seeing that process. I've seen it take as long as 18, 24 months.
That's crazy.
Yeah, exactly. Because, a developer's maybe accepted an offer by a DNO, and the DNO's maybe sat on it for 12 to 18 months before they've then submitted it to the transmission network operator.
Yep.
And that creates a lot of connection queuing challenges. And it'll come back, we will come back to this later, where, I was saying, is the problem actually the network's technically overloaded, or is it a bit of a mess in the whole connection queuing and more of a process thing? And well, the answer is probably somewhere in between.
Yep.
Back to just what I was saying. So that obviously then brings disadvantages to distribution connected customers as well, because they don't get a queue position in the transmission capacity world until the DNO's made that application and followed that process through.
So their original application date isn't relevant in the transmission queue.
Exactly. So it then falls more to when the DNO has submitted their application. And normally the DNO will group a few applications together, to make the process more efficient before they submit to National Grid.
So nearly like a batch process. They nearly kind of working it that way, sort of to try and
batch them up and submit them in. Yeah. And this is one area where different DNOs have different approaches to this. Some DNOs are, trying to rigorously implement, submit the next batch every 3 months. Some are taking a lot longer.
Yep.
And then obviously,
while that's going on, is there a pilot applications going into National Grid for transmission connections?
So that is your other inflow of connections, is direct into transmission level. So obviously, if you're sitting there in the DNO's pile for 18 months waiting for them to submit you to Grid, the activity at Grid level of people just going directly with 500 megawatt, 1 gigawatt applications direct into transmission, that's happening fast and furiously. So you're getting bumped way down that queue while you're sat in the DNO's desk. Yeah. So there's an issue there in terms of process and how that process aligns. There's been a lot of talk around joint up connection queues and trying to standardize. like, because at transmission level as well, your queue position isn't defined by application date, even if you are direct applicant to transmission. It's defined on, I can't remember now. It's either the date you get the offer or the date you accept. I think it's the date you accept the offer.
Okay.
So again, there's even little nuances there around queuing
so
and
that
process.
adds in another bit in terms of however long National Grid take to get that back out. And then I suppose different clients will have different processes in terms of accepting an offer and paying for an offer. Some will have an investment process they have to go through. Others will be able to do that quicker.
And DNOs will have different processes in terms of accepting the offer that comes back to them from National Grid as well, and how they divvy out the securities and liabilities and things as well. So again, I'll maybe just focus on maybe trying to get through a few of these more at high level, and we will delve into them. But just as another example of process alignment or misalignment, at distribution level, developers will be very familiar that you need to have a letter of authority from a landowner and a defined land boundary to show that you have a real you've got land to build your solar farm or battery or whatever it is. Which makes sense. At transmission level, that isn't a requirement. So I could go in tomorrow with a 5 gigawatt application and book up that capacity for not a lot of money really, without any prospect of me having any land or a feasible project there.
So this is kind of back to that virtual car, real car scenario. What actually is real bona fide projects that are shovel ready or are going to progress, as opposed to speculative. Well, it'd be nice to have 5 gig there.
Yeah, exactly. So you can kind of see where I was going with asking that question. Is there actual technical network issues here, or is part of it this kind of gridlock of a queue trying to get into the system?
We'll see on that. So in terms of volume then, what sort of levels of volume are these applications? Like, is it 10 gigawatts or is it thousands of gigawatts? Where are we at?
So I am going to refer to my notes on this one to get the numbers kind of right. So at the minute on the transmission connection, transmission entry capacity register, to give it its full name, there's over 1,000 generators in that queue. I think it's over 330 gigawatts. That value will be out of date as soon as this podcast published. That 330 that is
huge.
It's probably already 340 or 350 by the time we've even recorded this, and about 75 gigawatts. So that's already connected. I think somewhere between 75 to 100. I can't remember exactly. So there's a huge queue to connect there with accepted offers, and that is increasing day and daily. And then I think, roughly speaking, there's another 70 to 80 gigawatts in the distribution queues below that, which is additional.
Okay. So max demand in GB system sort of 50 to 60 gig, is it something like that from memory?
Somewhere around that. So Mac peak system demand on a cold winter's night in GB, I think it's in around the 55 gigawatts, somewhere between 50 and 60 gigawatts. So, we're sitting with, probably a queue of generation to connect somewhere in the region, probably 400 gigawatts ish at the minute. So, just to put the whole thing in context, that is quite a big queue. To look at National Grid's future energy scenarios in terms of net zero and where we're going and how much renewable generation we need, I think National Grid in round, I can't remember if it's 2030 or the early 2030s, they're predicting that we'll need about 150 to 200 gigawatts of capacity. And then by 2050, it's in the region of 300 to 350 gigawatts, depending on what scenario plays out.
Yeah.
So,
and those scenarios look at things like electrification of heat, transport.
Incorporates all of that into it. And it's kind of right in a net zero world, what is our generation mix and how much capacity do we need? So just to, by 2050, they're saying it's in the region of 300 to 350 gigawatts. Well, we probably already have that in the queue. If
it's real.
Yeah, so this comes back to that point.
Yeah.
But if everything in the queue was to connect, we could probably meet our 2050 targets. But that is the big caveat. Well, how much of that is real? How much of it has no prospect of getting land or getting planning? We know there's going to be big attrition rates here.
Yep.
And that bit around attrition rate, that will feed into some of the technical solutions that National Grid are progressing. So we will come back to that piece as well. So a big question is, how, when you factor in the attrition rate, how big does that queue actually need to be to hit 2050? Is the attrition rate 50% or what is it? So that's a bit interesting in a way. And that really feeds into that piece around, well, how much of this is this queue and speculative projects sort of gumming up the system, and is it actually a hard capacity problem at this stage?
And I think when you're talking about those volumes, it is likely that it's both, isn't it? In stages. It'll be an element of both.
It will be, yeah. So we'll come to that then in the solutions, because the solutions cover both. It covers trying to weed out the speculative applications, but also then trying to be smarter with the actual network capacity as well. So it's trying to free up from both ends a bit.
Yeah. And what about those technical challenges then, like high level summary of those? What are they?
Yeah, so that's kind of the process stuff covered at a high level, and we'll delve deeper into it in a future episode. In terms of technical engineering challenges, one of the big ones has been battery storage, the battery boom. I think between hybrid projects and battery-only projects, there's something in the region of 80 gigawatt kind of pipeline of batteries in the connection queue.
Yeah, more than the actual peak demand.
Yeah, exactly. Huge, massive, crazy. So there's been a significant kind of boom in batteries, both at transmission and distribution level, which again, it is really great to see the market interest in this and the investor kind of capital stepping up to the mark for net zero.
Yep.
So that it is a good problem to have.
And batteries can be a key enabler.
So this is it. This is the point exactly. Everybody expected batteries to come on and help the grid. The issue is basically there's what's called connection planning assumptions, CPAs for short. And that's basically what the rules that National Grid use to model out their network.
Yep.
And effectively, as it stands at the minute, when they're modeling batteries, they have to model the battery importing power at its peak, at a peak import period. So at say a T time peak, they're modeling that the 50 megawatt battery is importing 50 megawatt of power, which obviously puts huge pressure on that local grid and probably the wider transmission grid in that area as well. Now, I think that everybody raises an eyebrow at that, and they're like, why would a battery import at the most expensive period in the day, at the period that also breaks the grid? So we'll touch on solutions, but National Grid have done a lot of work with battery developers, and basically they're going to change how they model batteries then and change those assumptions. So that in itself will unlock capacity. How much is a big question, and again, we'll delve into that a bit when we come to it in one of the future episodes.
Okay, perfect. Okay, so that's a summary then of the technical issues. We at high level, we have summarized some of the process issues. Maybe get into a wee bit more detail, but that'll come later again. And then we'd already give a sort of an overview of transmission, distribution, how that all operates together. So in terms of what's next for us, that's kind of episode 1, scene setter. That's how we're going. What's coming down the line now? Yeah,
so to break it up then, in our next episode, probably across 2 episodes, we'll jump into some of those process-related issues in a bit more detail. So I'd say we'll do the next episode, probably focus on the processy and the kind of queue stuff and work on
like time stamping, date stamping, putting.
Well, maybe not get that far.
Okay.
But anyway, so things that we'll cover is the tech amnesty that National Grid has out. That's been extended into April, as far as I'm aware, which is basically allowing people to leave the transmission queue for free. There normally would be penalties and things associated with it. New queue management milestones that they're bringing in through a CUSC mod, a new 2-stage transmission connection offer process. So there's lots going on. They are genuinely trying to move things forward and move the dial on this.
It'll be good to hear some of those solutions.
Exactly, and probably one of the key things for anybody looking to invest or develop projects is mainly timescales for some of these solutions and what is the likelihood of it having a positive impact on people.
Yep.
And we'll look to wrap up on some of that and our views on some of that as well. And then in terms of the technical solutions around the connection planning assumptions, the CPAs, how National Grid are changing how they model batteries, and some of that stuff as well, alongside some of the local technical solutions they're deploying through the regional development plans, RDPs for short, where basically it's a process that allows the DNO and the transmission system operator to kind of team up on a local area at a GSP level and look at bespoke technical solutions for that GSP. So we'll talk a little bit about that and where that's got to when we cover the technical solution piece.
Perfect. We do love a 3-letter abbreviation though in the industry, don't we?
Yeah, I'm trying to avoid it as much as I can. You've tech and DNO and everything else. And so basically this is all stuff, I think if you're investing in renewables or battery storage, if you're developing it, it might even be useful to know if you're an engineer in the industry as well, whether you're in a DNO or whatever. So we'll cover all that, and then we'll try and pull it all together in a bit of a summary in terms of mainly focus probably for investors or developers or those kind of people trying to come into the industry with solar and wind and battery projects. A bit of a summary of, well, how is this going to impact you? When do we think these solutions might come online? What do we expect the impact to be? And where does this sit in your business plans if you're looking to develop renewable and battery storage projects in 2023 and beyond?
And a lot of it's being informed, isn't it? Actually understanding the process, what's it going to look like, and then you can set a plan in place and deliver against that, as opposed to...
Well, a big part of this is, National Grid and the DNOs, they do need, the bigger pool of people that understand what's going on and can participate constructively with them. I know some of the DNOs have been quite vocal saying, look, we do need your industry's help on this. Please, join us constructively. To quote one sort of senior member from a DNO at one of the forums I was at, he did say, look, like they really want to get people connected, but it probably isn't going to happen at the speed everybody wants it to, or that they want it to. But it's just going to take industry and the DNOs and everybody sort of working together to kind of push through this. Yeah, so I think on that note, we'll just thank everybody for listening. We will be doing the follow-up episodes in this mini-series in the coming weeks. As we said, please do subscribe on YouTube, Spotify, or Apple Podcasts, or wherever you get your podcasts. You can also ask us any questions. We're very keen to hear any feedback, get any questions, any ideas for future episodes. Please do. You can comment on YouTube, you can comment on LinkedIn, or you can email thegrid@esmartnetworks.co.uk as well, and we will pick that up. So thanks very much, and we'll see you in the next episode.
Thanks, everybody.